For today, what we're going to do is we're going to look specifically at skill 9D, which is solve basic polynomial equations. Right now, we're just basic. We're going to do some very basic maneuvers on those equations. And then in 2 chapters, we're going to get more involved, and we're going to start factoring more. Okay, so just kind of keep that in your noggin as we go. So today we're going to solve polynomial equations in factored form. It is section 9.4 of your book. Now, let's take a look at this. If I were to have 2 numbers, and let's say it's A and B, and they are equal to 0, what must one of those 2 numbers be? They must be 0, okay? So what we're going to do is this x plus 5, that's kind of like our A, and the x minus 4 is kind of like our B. So what I'm going to do is I'm going to set each equal to 0. So I'm going to go x minus 5 equals 0, and I'm going to go x minus 4 equals 0. So I'm going to set them each equal to 0. And then I'm going to use my algebra magic, and I want you to show your work as you do this. You're going to add 5 to both sides. X equals 5. And then in the other equation, I'm going to add 4. So x equals 4. Okay? And I'm done. That's what the problem entails. Now, you can ask, well, why do you do that, Mrs. Medvick? Let me show you a little bit. You would not have to do this on assignment, but I want to show you why this works. So if I have x minus 5 and x minus 4 equaling to 0, if x equaled 5, let's say, I could go 5 minus 5, 5 minus 4. Notice that 0 times 1 equals 0, so 0 equals 0, and it works. See how that works? Or if I had x equaled 4, see how it works? If I plugged in a 3, if I plugged in a 10, if I plugged in another number, do you notice how it wouldn't equal 0? So x can be 5 and or x can be 4, and that works. Okay? Let's go to the next one. Okay, so I'm going to let the first part, x plus 6, set it equal to 0. And I'm going to go x minus 3 equals 0. Very much like hands-on equations when we did it at the beginning of the year. Okay, so the first equation, what do? I'm going to subtract 6 from both sides. So x equals negative 6. On the other equation, I'm going to add 3. So x equals 3. Okay. Questions? All right, that's the first part. Now, keep that in your head. We're going to go to this right now. We're going to bring the 2 together in just a few minutes. Notice this asks us for the greatest common factor, or the GCF. Now, you're going to use it here. You're going to use it in geometry, and you're going to use this in algebra too. When you take your MCAs, your NWEAs, your ACTs, you're going to use this skill. They're not necessarily going to say, find the GCF. They're going to have it embedded in a problem and assume you know when to use it. Okay, so it's a really important skill. Notice that in this polynomial, there are 2 terms. Okay, so what we're going to do is we're going to put 1 like this, and underneath it, we're going to write 1 like this. Okay? Now you're going to use something called a factor tree, and you've all done this before. Okay, I'm going to take 16, and I'm going to break it down. What can I break it down into? 4 and 4. Okay, so I'm going to break it down into 4 and 4. Are they prime numbers? No. So I'm going to break 4 into 2 and 2. Are they prime? Yes. So I'm going to circle them. And the reason why I circle them is I know that they're prime and they help me with my list later. It doesn't become all these jumbled numbers. It kind of helps. And then this one is also 2 and 2. Right? So then I'm going to list this as 2 times 2 times 2 times 2 times x, because you'll notice it's 16x. I don't put the x in the tree. I don't need to. Okay. All right, so now let's look at 40. I want to break 40 down. What can I break it down into? 4 and 10. Are they prime? No, I can break 4 down into 2 and 2 and 10 into 2 and 5. Now, I can break 4 down in a different way. I could do 2 and 20 and keep breaking it down. I'm going to get the same at the end. Okay, I'm going to get the same factors. So I'm going to put this in order as 2 times 2 times 2 times 5 times y. Notice how I list them in order, numerical order. You want to do that because it helps you when you do GCF. All right, so now my GCF equals, right? Let's look at what they have in common. So this has a 2 in common. When I circle it, I write down 1, 2, because they have that in common. So as I circle it, I wrote it down. Don't put 2 down, 2 2's down. Just put 1 for right now. Okay. Now I'm going to circle another 2. So I'm going to put a 2 down. And then I'm going to circle another 2. So I'm going to put another 2 down. So my greatest common factor then is 2 cubed, or it's 8. And I'm done. Questions? Have you seen this before? Yeah, you've done it a lot before. You did it in 7th grade and 8th grade. All right, let's keep going. Let's look at the next one. All right, I'm going to put the first term down. It's 6x squared, and I'm going to put 30x cubed. Now, do I need to make a factor tree for 6? I could, but what are the two numbers? 2 and 3, right? So, like, I don't need to because it's only 2 factors. So 2 times 3, and then how many x's? There's going to be 2 of them because it's squared. Okay, now let's look at 30. 30 is a bigger number, so I'm going to use a factor tree for 30. What would be the factors? 2 and 15. Are one of them prime? Which one? The 2. So I'm going to circle it. Okay, 15 breaks down into 5 and 3. Are they prime? So I'm going to circle them. So then I'm going to come over here and I'm going to list them. 2 times 3 times 5. How many x's? 1, 2, 3. Good. So now I'm going to look at my greatest common factor. What can I circle? I'm going to circle a 2, and I'm going to write it down. And then a 3, and I'm going to write it down. Is there anything else? Yep, what? An x and an x. So what is my greatest common factor? 6x squared. And I'm done. Make sure your exponent looks little and to the upper right, because I have a lot of students that are writing it big. It looks weird. Okay, it's little and to the right. Questions on greatest common factor? Okay, we're going to put this all together now. Notice this says solve the equation. So step 1 is going to be make sure the equation is in standard form, because they aren't always in standard form. Is this in standard form? Yes. Why is it in standard form? That's correct. The highest exponent is first. Everything's to one side, and on the other side there is a 0. Okay, there's a 0. Okay, so that is in standard form. Now we're going to go to step 2, and it's going to be find the GCF. Okay, and on your MCAs and on your ACTs, they won't have steps there for you. They'll just give you something like this and say solve. There's many different ways to solve this. This is just one way. All right, we'll do more later another day. So I'm going to set up my terms. 3x squared 15x. So let's break the 3 down. What do I get? It's 3 and 1. 1 I don't put because who cares, right? It's just 3 times, good. Okay, 15. What are the factors for 15? 3 and 5. So I don't need to make a factor tree. Those are pretty basic. Times 5, or x. Okay, so my greatest common factor, let's circle them. Okay, what is it? It's a 3. Circle, write it down. Get into that action. So a lot of kids had trouble with that last year. And the other one is x. So that's my greatest common factor. Questions? Okay, so far pretty easy. Next step I call the leftovers. This is why I call them the leftovers. You know, on Thanksgiving, where you have that yummy Thanksgiving dinner, and like either later that night or the next day, you get the leftovers. It's almost better than the day of a Thanksgiving feast, right? And it's super, it's in the refrigerator, you warm it up, you eat, it's super yummy, right? Okay, step 3 is what I call the leftovers, and this is what I mean by that. We're going to take the GCF and we're going to put it out front. We're going to go 3x, okay? And then I'm going to do a parentheses. Now, if I take a look in step 2, do you see how there was something in 3x squared that I didn't use? Do you see there's an x there? Okay, this x right here, I'm going to write down. It's my leftovers. It's what I have left over from my GCF. Then I'm going to take a look at the original problem, and do you see there's a sign right here? Sometimes it's a plus sign, sometimes it's a minus. I'm going to put that down. It was a plus. And then look at the second term, the 15x. Is there a leftover? What is it? It's a 5. So I'm going to write that down, and I'm going to put a parenthesis. That's the leftovers. Okay, and then step 4 is going to be solve. And you've done this piece already. In fact, this was the very first problem that you had. We're going to take 3x and we're going to set it equal to 0. And then we're going to take x plus 5 and we're going to set it equal to 0. Okay, remember from the beginning? So how do I solve for x on this one? Divide by 3. So x gives me 0. What do I do on the other one? Subtract 5, x gives me -5. Okay? And you go, Mrs. Medvick, what does that mean? Like, what's going on? If I were to graph a parabola, this parabola crosses at -5 and 0. That's what you're finding. Okay, and we haven't graphed parabolas yet, so you can go, well, what the heck? You're going to see that later. We're going to graph them in the next chapter. So this we're going to pick up after that chapter, but it's important to know these skills. So I'm going to do a couple of things right now, and then we're going to leave it for a minute, and then we're going to come back and we're going to pick it up. Okay. All right, let's look at the last problem. Let's look at these skills. What do we do first? Before the greatest common factor, standard form, yes. So I am going to do what for standard form? Sure, subtract 24b. So I get 9b squared minus 24b equals 0. That's the first step. Now, you could have subtracted 9b squared. However, most of the time we like that first term in the polynomial to be positive. We really like that. Okay, so that's why I left the 9b alone, 9b squared. All right, now we list our terms. So I'm going to do 9b squared, and I'm going to go 24b. Notice how I left the sign alone for right now. Break the 9b squared down. What do I get? 3 times 3 times b, right? Now, the 24 is larger, so I'm going to do a tree on that one. What do I break it down into? 2 and 12, circle to 2. 6 and 2, circle to 2. 3 and 2, circle them. Because they're prime. What does prime mean? Can't break it down anymore. It's only one in itself, right? All right, so I'm going to write them in order. I got 2 times 2 times b. So my greatest common factor, what do I circle? I'm going to circle a 3, and I'm going to circle a b. And it doesn't matter which one you circle. Okay. What's my next step? My leftovers, right? Yeah, my leftovers. So I'm going to put 3b out front. What's my leftovers in the first term? The 3 and the b. And you don't have to circle them in your homework, but I tend to do it so that people can see it on the notes. Okay, what sign goes in between? It's a minus, and you're going to see it right up here in the red. So put a minus. What's my leftovers in the last term? 2 cubed, or 2 times 2 times 2, which is 8. There's my leftovers. Now what are we going to do? We're going to solve. So what do I get? 3b equals 0, and 3b minus 8 equals 0. What do I do in the first? Divide both sides by 3. b equals 0. So the parabola, I know, crosses the x-axis at 0. What about the other one? Add 8. 3b equals 8. Divide both sides by 3. b equals what?
27.
No. 8 divided by 3 is? You did 3 divided by 8. Okay, 2.6 or 2 and 2/3. Or 2.6 repeating. Okay. And that's where it crosses the x-axis.